Hello and welcome. Today we're going to be discussing section 8.2, which is on perimeters of composite figures. Composite figures, this word composite, comes from the word compose, and all this means is that we're taking two shapes and putting them together to form one shape. Our essential question is, how can you find the perimeter of a composite figure? So first, for a definition, a composite figure is made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. And here's a couple examples. This entire blue shape is a composite figure because it's composed of a square and a triangle. We put this square on the left together with the triangle that's on the right. We put these two together to form the entire blue figure that we have. On the right, the orange figure is composed of a rectangle on the bottom, so we're looking here at this bottom shape, that is a rectangle. And on the top, we have this round shape that is half of a circle or a semicircle. Semi means half. So we have a rectangle and half of a circle or a semicircle. So what we're going to be moving into is finding the perimeters of these composite figures. So we have more than one shape that we're putting together, and we're going to combine them and find the perimeter of that total shape. First thing I'm going to do is show you a brief video explaining how to find the perimeter of an object that's in a grid like this. All we want to know is what is the entire distance around a shape in a grid. So essentially all we're going to do is count how far we need to go to make it from one point on the grid, if maybe I start here, how far do I need to go to walk all the way around the outside of this shape. So in this brief video, we'll go ahead and see an introduction on how to count these perimeters.
To find the perimeter of this object, what we are going to do is pick any starting point on the outside of this shape. I'm going to start with this point right here, and I'm going to jump from one grid mark to another grid mark, and that would be a distance of 1 unit. For example, from here to here is a distance of 1. So we make 2 and 3, and we can go all the way around and just continue counting by ones. So this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So just by using the grid located on the outside of this shape, we could just count by ones all the way around, and we would say the perimeter of this object is equal to 20 units. Another way to calculate the perimeter of the shape would just be to figure out what the length is of each side and then add all of those sides together. This side right here has a length of 4, this side has a length of 1, this side here has a length of 2, this side has a length of 2 as well, this side has a length of 2, this side has a length of 1, this side has a length of 4, and this side also has a length of 4. We have 3 4s, and 3 times 4 is 12. We have 3 2s, and 3 times 2 is 6, and we have 2 1s, which gives us a sum of 2. Adding all of these numbers together, we still come up with the answer of 20 units. That would be the perimeter of the object shown on the grid.
So all we're going to be doing is counting how many segments it takes to cover the outside of our entire figure. So if I start here at this corner, I'm going to cover this first top side, and I see there's a length of 1, 2, 3, 4, 5, 6. A length of 6 to go across this top side of my arrow. I always like to make sure that I outline after I've counted. That way I know that I've taken into account this side of my shape. Now this vertical line I haven't outlined yet. There's no blue mark on it, so I'm going to go ahead and count this distance. I see 1, 2. So this has a distance of 2. So to get from the left to the top part of my arrow, I would have a distance of 8, 6 across the top and 2 vertical. Now we haven't talked about these diagonals yet, so I'm going to go ahead and skip over to this left side. The left side I go straight down, 1, 2, 3, 4 for a distance of 4. Across the bottom I go a distance of 1, 2, 3, 4, 5, 6, total of 6, and then I go down 1, 2. So to cover this left side of my arrow, I go 2 plus 6, which is 8, plus 4, which is 12, plus 6, which is 18, plus 2 more, which is 20. What we haven't taken into account are these diagonals of my arrow. Now I know if I were to go straight across the edge of this box, that would be a distance of 1, and I know if I were to go straight up, that would be a distance of 1. However, we're actually going diagonal, so we're not talking about a distance of 1. Now I want to look at this in terms of a square in a separate example. Now in this square, imagine that this square is just one of these from our grid, just enlarged. We just made it larger. So for example, on this bottom side, I had 1, 2, 3, 4, 5, 6 squares, and I was counting 6 of the edges of the squares. This is just one edge of my square, so this red mark is going to represent a distance of 1. So that red mark represents a distance of 1. Now I can take this red mark and I can turn it so it's lined up with the left side of my square. So if I go ahead and do that, I can see that this left side of my square has a distance of 1 as well. The left side has the same distance, that same red length that the bottom did. Let's go ahead and bring it back down to the bottom. So that distance is 1. Now what I want to know is what is the distance across the diagonal? What's the distance from this point to this point here? That's what I really want to know. Because in my arrow, that's what we're talking about. We're talking about the distance from one corner to the other corner diagonally. So I'm going to go ahead and take this red segment and turn it so that I can compare it to that purple segment. Now what we can see when we look at it this way is that this red segment is shorter than the purple segment. This red segment has a length of 1, but the purple segment is longer. The purple segment has this extra distance here, so it's longer than 1. It's not quite double the length. If it were double the length, this red segment would be extended twice as far, and it would probably end somewhere about here. So it's not twice as long, it's just a little bit longer. So what we can say is that the red length, if I were to count just the red, is 1, plus a little bit more. We can just add on a little piece and say, let's actually call this 1, but then a little bit more, so let's call it 1.5. So this entire diagonal is the length of 1 red unit plus about half more. So anytime we're talking about the length of a diagonal, we'll just say it is 1.5. So for example, if the length of this box were 1 foot, the length of the diagonal would be 1.5 feet. You can think about in a room. If you go along the edge of a room from one side to the other, that's shorter than going from one corner of the room diagonally across to the other corner of the room. If you look at the room you're in now, you'll be able to see this. One side of the room is definitely shorter going from corner to corner across the wall than it would be going from corner to corner diagonally. So we're going to go ahead and call this 1.5, and now I can go ahead and count the diagonals along my arrow. So corner to corner, diagonally, that's 1.5. Another diagonal gives me another 1.5. Another diagonal from corner to corner gives me 1.5. And another diagonal from corner to corner gives me another 1.5. Now when we count the bottom part of the arrow, it's going to be exactly the same as the top. So from corner to corner is 1.5 and 1.5, 1.5, 1.5, and all four of those will add up to a total distance of 6. 1.5 plus 1.5 is 3, and then another 3 to give me a total distance of 6. So all I did is I added up that 1.5 4 times. Now from here, we can get out our calculator. Remember that if you want to do it by hand, you may. And I'm just going to go ahead and add up all of the numbers around the outside of this figure. It's probably smart to check them off as you go, just so that you know you've covered them all. I've got 6 plus 2, so I'll start with that. I'm going to start with this 6 and then the 2 that's vertical. 6 plus 2, and I get 8. Now we can go back and mark those guys off. We added them up. And I'll keep going. I'm going to add these 4 1.5s. So plus 1.5, plus 1.5, plus 1.5, and my fourth 1.5, for a total of 14. If you want to just add 6 instead of adding the 1.5s 4 times, you may. I'm going to continue down my arrow and add in the 6 for a total of 20. And then I'll add the 2, the 6, and the 4. So plus 2, plus 6, and plus 4 for a total of 32. I added my 2, my 6, and my 4, and I got a total of 32. Now notice that all of my edges have been marked off. I've counted the entire outside of my figure. So this is my final answer, and the distance around the outside is a total distance of 32 units. We don't know what these units are. They could be inches, feet, miles. It really doesn't matter. All we know is that there's some sort of units, and there are 32 of them around the outside of this figure. Number 1, we'll go ahead and practice the same thing. I like to do those vertical and horizontal pieces first, so I'm going to start with the top and the bottom of this figure. On the top, I've got 1, 2, 3, 4, 5, 6, 7. Total distance is 7. And on the bottom, I should have the same. 1, 2, 3, 4, 5, 6, 7. And I do. Now the diagonals are what get a little bit tricky. Remember that from corner to corner diagonally is a distance of 1.5. So corner to corner diagonally, this is 1.5. There's another diagonal here from corner to corner of my box. That's another 1.5. Corner to corner, a third time, is another 1.5. Along the bottom, same thing, 1.5, 1.5, 1.5. I've got 3 of them. And on this right-hand side, 1.5, 1.5, 1.5. I've got 3 of them. And lastly, 1.5, 1.5, 1.5. I've got 3 of them. And now we just go ahead and add all these things up. Now to add, we can go ahead and write 7 plus 7. And then we can check these guys off and say, all right, we included those. But then I have all these 1.5s, and I really don't want to add up all of those separately. So what I'm going to do is count them and see how many there are, and then just multiply. So I am going to add the 1.5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So I am adding 1.5 12 times, or just times 12. And now in our calculator, we can go ahead and punch all this in. I've got 14 plus 1.5 times 12. I'll go ahead and do that part first, and then I'll add the 14 in after. So here's my calculator. I've got 1.5 times 12, and that gives me 18. So 14 plus 18, which you can use a calculator for if you'd like, but we do end up getting 32 units again. So, just to recap, what we have found is that the distance around the outside of this figure, or the perimeter of this figure, is a distance of 32 units. If you were to walk around this figure, you would walk a total of 32 units, whether it be feet, miles, yards, again, we don't know. I'd like you to go ahead and take a moment to practice number 2 on your own. I'll go ahead and start here at this point. Remember, I just go vertically 1, 2, 3, horizontally 1, 2, 3, 4, 5. I go vertically 1, 2, 3, 4, 5, 6, 7, 8. And I go horizontally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I then add in my diagonals, which is going to give you a total distance of 7.5. Adding all of these numbers together, we get a total distance of 33.5 units. That's all I have for you today. Thanks so much for watching.